Can anyone answer A, though? Where does the graph touch the y-axis? 0, 1. Good, that's our y-intercept. What is the domain for this function? What's the domain for this function? What x values does this function use?
0 through 2.
Just 0 through 2? But I put arrows at the end. Infinite? Yeah. We're going to go all real numbers. Negative infinity to positive infinity. All real numbers. Fantastic. What about the range? What about the y values? What do you got, sir?
0 is less than or equal to y.
0 is less than or equal to y. Okay? You could write it that way. I'm going to write it the other way. Y is greater than or equal to 0. It's the same thing. You just flipped it.
I thought it was 1.
Why is it 1?
Because it's like that 1 on the y-axis.
Oh, but check out this part of the graph. It's going to keep getting infinitely smaller, but that's our next question. Do you think the graph will touch the x-axis? No. It's getting smaller and smaller, but it won't touch the x-axis. Why is a good question. You ready for my math answer? Anyone still writing before I show you why? Why won't it go into the negative region? You ready? Okay, here's the reason why. I made a table. Right? I made a table at 0, 1, 2. We were okay with that, right? 5 squared is 25. If I go backwards, what's 5 to the negative 1? Ooh. Try it in your calculator right now. Try 5 to the negative 1, please. 0.2. Okay. Now try 5 to the negative 2. What do you get? 0.04. How about 5 to the negative 3? Can you put that in your calculator? What are you getting?
0.008.
You said 0.008? Why am I getting decimals? Anyone remember your negative exponent rules? Like 5 to the negative third is really 1 over 5 to the third? It's creating a fraction. Negative exponent rules? I know, Algebra 1. It's getting smaller. It is never getting negative, though. It's just getting smaller. Okay? Great. Next. You are going to graph 3 different graphs. But you can use Desmos. You're going to identify the y-intercept, the domain, the range, the asymptote. Uh-oh, new word. Look at this word. Say it with me. Asymptote. There we go. That's a math word. Okay? An asymptote, we'll do the first one. The first one, y equals 2 to the x. The y-intercept is going to be at 1. What's 2 to the first power? What's 2 to the first power? 2. What's 2 to the second power? 4. What's 2 to the third power?
2 times 2 times 6.
Yeah, what's that? 2 times 2. 8. So let's graph it. Boom. 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 That's your first one. This is our first one. We'll fill out the first part of this table. It's got arrows at the end. The y-intercept is 0, 1. The domain? What's the domain for this function? Negative infinity to infinity. What's the range for this one? Greater or equal to 0. The asymptote is going to be y equals 0. It's never going to cross this line. It's never going to cross that line. Okay. Do we need more time for our graphs? From this table, from our graphs, what do you notice? What do you notice? Can you tell me something you notice? They all have at 0, 1. They all start at 0, 1. Why is 0, 1 a special point for a graph? What point is that? What's it called? Yay, thank you. It's the y-intercept. They all have the same y-intercept. Anything else that you noticed from our graphs? Domain's the same. Range is the same. This new funny word, asymptote, they all are not going to be below y equals 0. They're all positive. An asymptote is just telling us a line that'll never go across. So none of these are going to be negative. They'll never go below y equals 0. Anything else that you notice with the graphs? What? They all have the same point of intersection? Yeah, they're all going through here? That's great. Yeah, they're all going through 0, 1. That's a point of intersection. Anything else? They're all going up. They're all going up. You're so close. 2 are going up. What's this one doing? This one's decreasing. I love it, Casper. 2 are going up. 1 is going down. So make a note. Y equals 1/2 to the x. This was decreasing. That one was special. It's decreasing. Okay, next page. We've got more graphs to look at. Now we're going to graph y equals 2 to the x. That's kind of our parent graph today. Y equals 2 to the x. We've graphed that one a lot. Do note that we changed the scale here. Can you see how it's going by 2s now? So I'll graph the parent graph. This is my parent graph. Y equals 2 to the x. It still has an intercept of 0, 1. It still has a domain of all real numbers. It still has a range of y is greater than 0. It still has an asymptote of 0. But now I want you and your group to type these equations in and graph them. What's going to change? You guys ready to discuss? Because we still have one more graph to do in Desmos. What do you notice about these graphs in this table? I feel like I heard Gabe say it. Gabe, what did you say?
The y-intercept is the number in front of it in parentheses.
The y-intercept is the first number in the equation. Do you guys see that? So 3 times 2 to the x, 3 was my y-intercept. 1/2 times 2 to the x, half was my y-intercept. Which one's growing the fastest? Which one? The second one? Yeah, it's growing faster. It's more steep. We still have the same domain and range. We still have the same asymptote. It's not going to go below y equals 0. And I'm going to add the asymptote with a dashed line on this graph and highlighter. This is my asymptote, y equals 0. That's my asymptote. It won't go below that line. You ready for one more graph? We're going to change one more graph. Number 4, you're going to graph y equals 2 to the x plus 1. then 2 to the x minus 3, and then careful, the last one is y is 2 in the power is x minus 1. If you need help typing the next one into Desmos, please let me know. Right now you're on this next one. Here we go. All right, I graphed the first one up here, and I did put a dashed line for my asymptote. When I add 1, it's shifting this graph up 1, so now I won't go past y equals 1. Do you see that, how it's shifting up and down? It's also changing our asymptote. The line it will not go below. It won't go below y equals 1. So then for the next one, how is this graph going to look? For this one. If it's 2 to the x minus 3, how does it change? Can you picture that? Did you type it in decimals? It's at negative 3, so it's going to be down here at negative 3, and we can graph that one. Same shape, but now it's going to be shifted down 3 units. We'll graph that one. So the asymptote is at negative 3 now. Can we get some points? Here's the next one. That changes my intercept. What about your intercept for the last one? What was your intercept? Can you tell me from your graph on Desmos? Half? Yeah, 0, half, or 0.5. That's our intercept, so we can graph that. 0.5. That one's growing. This one has an asymptote of y equals 0 again. It did not shift up and down. Did it do anything else? How did it shift? Oh. And then we've got this general equation down here. Y equals a times b to the x minus h plus k. H and k, have we done h and k before? Did we do that earlier this year? Uh-oh. What did h do to a graph? Good, left and right. Remember, h moved our graph left or right. What did k do to our graph? Up and down. From the number 3 up here, what does a tell us? A special point. What does a tell us? Gabe said it earlier. What does a tell us? Good, the y-intercept. B tells us how we're growing. Exponential functions. For the most part, our y-intercept Our y-intercept comes from the a value. The a value. The domain? What's the domain going to be for an exponential function? Negative infinity to positive infinity. What's the range? Y is greater than or equal to 0. When b is greater than 1, we have growth. When b is less than 1, we have decay. Again, I'm referring to the equation we had on the last page. A times b to the x minus h plus k. This is what we're referring to. H, again, is left and right. K is up and down.